In this video, we begin with homework exercises for Chapter 1, Section 4. With problem number 11, we have a simple absolute value equation. Remember what this is asking is, what number or numbers are 6 units away from 0 on the number line? And we begin by setting up two equations. We have w equals 6 and w equals negative 6. And we're done. So if I were to go on and to graph this, I would set up a number line. Negative 6, positive 6. I know that 0 is in the center in this case, and each one is 6 units away from 0 on the number line. And so we found our solutions and we've graphed them as well. In number 13, right away we can tell that there are no solutions to this because an isolated absolute value can never be negative. And we'll go on to problem number 15. In problem number 15, once again we can begin by setting up two equations. M plus 3 equals 7. M plus 3 equals negative 7. Subtract 3 on both sides. We get m is equal to 4. And then the second equation, subtract 3 on both sides. We get m is equal to negative 10. When I go to graph this, I have negative 10 on the left, positive 4 on the right. I need to find the center, so that would be negative 10 plus 4 divided by 2 is going to give me negative 6 over 2, or negative 3. So my center is negative 3, and the distance from negative 10 to negative 3 is 7. The distance from negative 3 to 4 is also 7. So we can see what this question is asking is, what number or numbers are 7 units away from negative 3 on the number line? And so from this, we can see that whenever you have a plus on the inside of parentheses, what it really means is m minus negative 3 equals 7 in this case. So when you have a plus something, because our basic structure for the equation is x minus the center equals the distance from the center. So in this case it's going to be x minus negative 3, or x plus 3 is equal to 7. We'll go on to the next example, number 17. We have the absolute value of negative 3d is equal to 15. Here we have a negative inside the absolute value. And we can set up two equations. We have negative 3d equals 15. Negative 3d equals negative 15. Dividing both sides by negative 3, we end up with d is equal to negative 5. And on the other side, dividing by negative 3, we get d is equal to 5. So when I go to graph this, I'm going to see that this is equivalent to, when I have negative 5 and 5, I know that 0 is the center and that the distance between the two is both 5. So this equation really is the same as the equation x minus the center, or in this case d minus the center, which is 0, is equal to the distance from the center, or just absolute value of d is equal to 5. That would be an equivalent equation. Now how can we make sense of that with the original one? Well, we know that an absolute value can never be negative, so we can actually just take away that negative that's on the inside, but be careful with that. and then divide both sides by 3, we'd end up with absolute value of D is equal to 5. Alright, I'm going to scroll down and go on to the next two examples. With number 19, we have an isolated absolute value equals a positive number. So we set up two equations. 4b minus 5 equals 19. 4b minus 5 is equal to negative 19. We start by adding 5 on both sides, and we end up with 4b is equal to 24, dividing by 4, b is equal to 6. Add 5 on both sides of the second equation, we get 4b is equal to negative 14. Dividing both sides by 4, b is equal to negative 7 halves, or negative 3.5. So when we go to graph this one, we have negative 3.5 on the left, positive 6 on the right. We add the two numbers, so we get 6 plus negative 3.5 divided by 2, and that is 2.5 over 2, or 1.25. So our center would be 1.25, and calculating the distance between negative 3.5 and 1.25, we'd get 4.75. And you can do that by subtracting 1.25 minus negative 3.5, or by subtracting 6 minus 1.25 on the other side. And you'd see that you still get 4.75 as well. So, if we wanted to use that information to construct an equivalent absolute value equation that's simpler than the original one, we would go back to our structure, which is x minus the center, in this case b, minus the center equals the distance from the center. So these two absolute value equations are equivalent. The second one is simpler, and we can see what it's asking. What the original question is really asking is, what number or numbers are 4.75 units away from 1.25 on a number line? All right, let's go on to number 21. Number 21, we're going to first, before we set up the two different equations, we're going to divide by negative 4. So 8 minus 5n equals 13. Dividing both sides by negative 4 and canceling, we end up with absolute value of 8 minus 5n is equal to negative 3.25. If we wanted to leave that as a fraction, we'd have to leave it just as it is, because 13 is a prime number, and so it can't be simplified any more than negative 13 over 4. But at this point, we're ready to begin by setting up two different equations, and we'd have 8 minus 5n. Oops, I don't even need to do that, because we have isolated our absolute value, and the isolated absolute value is negative, is equal to a negative number, and that is not possible. So we say that there is no solution. An isolated absolute value cannot be negative, so no solution. So when you see that, you can stop at that point. All right, so that'll do it for these examples. We'll go on to the next in the next video.